Okay, now we have formation of hydrogen molecule. Here the electronic configuration of both the hydrogen atoms will be one electron only. Okay, now this is the nucleus of hydrogen atom, inside which there will be only one proton and there will be one electron. This is your second hydrogen atom, inside the nucleus one proton, and this will be one single electron. When these both atoms approach together, there will be overlapping of orbits. Okay, and both of these electrons will be shared. All right. So this is your formation of hydrogen molecule. Each of these hydrogen atoms, okay, you can see both of them are having 2 electrons in its first and outermost orbit. So both of these hydrogen atoms are completing its duplet state. Okay, now I can show the bond like this, H dash H. This dash represents a single covalent bond. Okay, in terms of electron dot structure also I can show. First I'm going to show this in the form of equation. This is one electron of the first hydrogen atom. This is the second electron of the second hydrogen atom after the bonding is taking place. Okay, this is your H2 molecule. Okay, so this was sharing of one electron each. In this case, we are having a single covalent bond which is represented like this. Okay, this is what I have drawn, is also known as the structural formula. Okay, and this is what I have drawn, is the diagrammatic representation of hydrogen molecule. The second example that we are considering is formation of oxygen molecule. Okay, so 2 oxygen atoms are over here. First I'm going to write the electronic configuration, which is going to be 2, 6. Okay, the atomic number or proton number of oxygen is 8. 2 electrons will come in the first orbit and 6 electrons will come in the second orbit. Okay, now here in the second orbit there can be 8 electrons possible to attain its octet state. Okay, so 2 electrons are short, therefore its valency is going to be 2. Okay, 2 minus you are going to write when there is going to be transfer of electrons. Here there is sharing of electrons, so how many electrons each of the atoms are going to share, that is going to be its valency. Okay, that we will see when ionic bonds are coming. Okay, so now here I can show the oxygen atom, the nucleus of oxygen atom. I'm showing only the outermost orbit. This is the symbol O. Okay, this is the outermost orbit. Inside this there are 6 electrons which can be represented like this. Okay, I have shown only the outermost orbit and the nucleus. After the bonding is taking place, when both of these oxygen atoms combine, the overlapping of orbits will take place. Nucleus remains as it is. Okay, the 4 electrons on the left hand side of the oxygen atoms are shown over here. These are the 4 electrons
of the
second oxygen atom. Now 2 electrons will be from the first oxygen atom and the other 2 electrons of the second oxygen atom. Okay, now if I'm observing both of these atoms, suppose if I'm considering this is the orbit of the first oxygen atom, how many total number of electrons are there in this orbit? There are 8 electrons. So this first oxygen atom is completing its octet state. Similarly here, the second oxygen atom also, if I'm considering, this is also having 8 electrons in its outermost orbit, so that is also completing its octet state. Now in between you can see how many electrons are being shared between these both oxygen atoms. There are 4 electrons. Okay, if I'm showing the structural formula or the structure of oxygen molecule, because there are 4 electrons, so this is going to be a double bond. Okay, I can also show this with the help of equation and electron dot diagram.
So every line is for one pair of electron shared.
Correct. Okay. So now here we are having the first oxygen atom. These are the 6 electrons of the first oxygen atom that is combining with the second oxygen atom.
Yeah.
Okay. Now 2 electrons from here and 2 electrons from here will get bonded.
Yeah.
This is going to produce
2 oxygen molecules.
Okay. It's one single oxygen molecule, which is having formula O2.
Yeah.
Okay, this is your oxygen molecule. 4 electrons are in between over here. It means this is going to be a double bond.
Yeah.
Okay. The next example that we are considering over here, that is formation of nitrogen molecule, which will be
N2.
So both of the nitrogen atoms, first thing that we are going to write over here is its electronic configuration. Proton number or atomic number of nitrogen is 7. Its electronic configuration will be
5.
Now you can see the outermost orbit is short of 3 electrons. So therefore its valency will be 3. Okay, so 3 electrons from each of the nitrogen atoms are going to get shared.
What if it's 2 and 4? What will the valency be?
We'll just come to that also. Okay.
Yeah.
So now nitrogen atom is over here. The nucleus. I'm not showing the first orbit. I'm going to show directly the outermost or the second orbit. Okay. Yeah. Now these 5 electrons, I'm going to show them like this. The 3 electrons that are shared of the first nitrogen atom, the other 3 electrons that are shared from the second nitrogen atom, and the remaining 2 electrons are over here. Okay. When both of these nitrogen atoms combine together, show the overlap orbits.
Yeah. And 6 in the
Okay. All right. Now here 6 electrons are being shared.
Yeah. Can there be 4 lines? No.
No. Quadruple bond between 2 carbon atoms is not possible because the electronic configuration of carbon is 2,4. Okay, we'll just take the next example now.
Yeah.
Okay.
Yeah.
We have shown here hydrogen, oxygen and nitrogen.
Yeah.
Okay, this phosphorus and sulfur, we will take it later. All right, we are considering now the covalent bonds of compound. Okay,
Yeah.
the first example that we are going to take over here is formation of HCl molecule.
One and
Proton number 1, proton number
17.
17. This you will get it from the periodic
Yeah.
table.
Yeah.
So its electronic configuration is 1.
1, 2, 8,
This will be 287.
Yeah.
Okay, hydrogen will be sharing one of its electrons
Yeah.
to make
State.
here also there is shortage of 1 electron to make 8 electrons in the outermost orbit. So here also 1 electron will be shared by
Sorry.
chlorine atom from the outermost orbit. This is going to make
State.
octet state. I'm going to draw the hydrogen atom first. There is 1 electron in the outermost orbit. Chlorine atom, I'm showing only the outermost orbit.
7.
7 electrons are over here.
Yeah.
When both of these atoms combine together, okay, this is your hydrogen atom, chlorine atom. The other 6 electrons will remain unaffected.
Yeah.
This will be the electron of hydrogen, this will be the electron of
Sorry.
chlorine atom. Okay,
Yeah.
now the bond that is formed, that can be shown over here like this. Here also there is a single covalent bond, but the electrons that are shared between hydrogen and chlorine atom, these electrons are not shared equally. The reason for that is chlorine is having greater ability to pull that shared pair of electrons more towards itself. Chlorine has greater ability to attract this shared pair of electrons. So this electron pair is going to be shifted more towards chlorine atom rather than hydrogen atom. This is going to develop a slight or small positive charge on hydrogen atom, which will be written as delta positive. This delta means very small amount of positive charge. Similarly here chlorine, because the electron pair is more towards itself, is going to develop a small negative charge, which is going to be delta negative charge. These kind of a bond that is formed where the shared pair of electrons are not, the electron pair is not shared equally, such a kind of a bond is known as a
Covalent bond.
covalent bond. Okay,
Yeah.
so although the bond is a covalent bond, but it is polar. Polar means it is polarized. It means one of the atoms is slightly positively charged, the other of the atoms is slightly negatively charged, because this chlorine atom is having greater ability to pull that shared pair of electron more towards itself.
So,
Okay, so this was polar covalent bond, that was for HCl. I can also show the electron dot structure for this. Okay, hydrogen is having one of its electrons. These are the 7 electrons in the chlorine atom.
yeah.
In this way, hydrogen is having its duplet state and chlorine is completing its octet state. Okay, this was the polar covalent molecule of hydrogen chloride gas, that is HCl gas.
Yeah.
Okay, this HCl gas, when it is dissolved in water, it becomes hydrochloric acid. Okay,
Yeah.
so this was HCl. Next is formation of water molecule, that will be H2O.
Yeah.
Okay, now see, hydrogen is having its electronic configuration 1. Oxygen is having its electronic configuration 2,6. So its valency, hydrogen needs one more electron to make its duplet state.
Yeah.
So its valency is 1. Oxygen requires 2 more electrons to make its octet state. So its valency is 2.
Yeah.
So if I'm writing the valencies of hydrogen and oxygen over the top, hydrogen valency 1, oxygen valency is 2. If I want to get the formula of this compound, I'm going to exchange these valencies, and the formula of the compound between hydrogen and oxygen is going to become H2O, which is nothing but water molecule. So it means in the process here there are 2 hydrogen atoms that will be sharing one electron each with single oxygen atom.
Yeah.
Okay, so the bonding can be shown over here like this with the help of the diagram. First I'm going to draw oxygen atom in the middle, the nucleus. The 6 electrons of oxygen atom will be represented like this. 1 electron I'll place over here, other electron I'll place over here.
Yeah.
Hydrogen atom is there, first the nucleus, second hydrogen atom, the nucleus with its 1 electron.
Yeah.
Okay, so over here these both electrons will get shared, these both electrons will get shared. Okay, I can show that water molecule with the help of the diagram. First the nucleus, these 4 electrons as it is, bonded orbits with hydrogen. Okay,
Yeah.
1 electron of oxygen, 1 electron of hydrogen. Same way on the
Other side.
side. Okay,
Yeah.
so the bond that can be shown over here will be like this. You can see in the process here oxygen atom is having 8 electrons over here
Yeah.
in its outermost orbit, so that is completing its octet state. Hydrogen, each one of the hydrogen atom is having 2 electrons in its outermost orbit, that is going to complete its duplet state. These both bonds that are there, these are going to be 2 single
Bond.
covalent
Bond.
bonds.
Yeah.
Okay, now these both pair of electrons that I have shown over here, this pair and this pair of electrons, these are known as bonding pair of electrons.
Yeah.
These 2 pairs of electrons that are shown over here,
Lone pair.
okay, we call them either non-bonding pair of electrons or simply
Lone pair.
okay.
Yeah.
These lone pair of electrons have some significance because afterwards this is going to come in formation of hydronium ion, as well as when we discuss ammonia, there the lone pair of electrons will be responsible for formation of ammonium ions. Those bonds are going to be your dative bonds.
Yeah.
Okay, so that part we will see later. We have finished.
Won't the hydrogen atoms be like towards the bottom because some force?
Oh yeah, that when we are considering bond angle and those things, at that time we will just consider those things. Okay.
Yeah.
When we are going to consider three-dimensional structures, okay, we will just take all those things into consideration.
Yeah.
Next part that is there is formation of ammonia molecule, which is going to be NH3. Okay.
Yeah.
Proton number is 7.
Yeah.
Here the electronic configuration will be 2 5. So valency.
Okay.
This needs 3 electrons to make octet, so its valency will be 3. Hydrogen needs 1 more electron to make duplet, so its valency will be 1. So similarly here we can write down nitrogen with its valency 3, hydrogen with its valency 1. I can exchange these valencies to get the formula of the compound. Okay, this is going to be NH3. This is your ammonia molecule. So first I'm going to draw a single nitrogen atom. I'm just showing the outermost orbit electrons. I'm going to show one pair of electrons over here like this. The other electrons will be shown will be this way. There are 3 hydrogen atoms that are combining together with a single nitrogen atom. Okay, these all will combine together. I'm going to show this molecule. First I'm going to draw the nitrogen atom. This will be your lone pair of electrons. Nitrogen nuclei. 1 electron of nitrogen, 2nd electron of hydrogen. Okay.
Yeah.
This will be your
NH3.
Yeah, ammonia molecule, but this will be your lone pair of electrons. And these are going to be the 3 bonding pair of electrons.
Yeah.
Okay. Next part is in terms of electron dot diagram. Okay. Nitrogen atom is over here. These are the electrons. Plus you can show the 3 hydrogen atoms separately, or you can simply show them like this. Okay.
But then you have to show 3 electrons, no?
Yeah, obviously this 3, when I'm multiplying, it means here these are 3 hydrogen atoms which are this way.
Oh.
Okay, so I can show the bond like this similarly. Okay, this is your ammonia molecule in terms of electron dot diagram or electron dot structure. Now the structural formula or structural diagram for nitrogen.
2, 3.
Okay, we are going to have over here 3
Hydrogen.
single covalent bonds. Okay, in your past paper, there are several kind of such questions asked that there are these many single bonds, these many double bonds in this molecule. So you'll have to work out the structural formula. Okay, and then you will be able to find out how many bonds are there in each one of these kinds of molecules.
But you get to know in the formula only, na?
Yes, obviously, but then you should know the formula. If you don't know the formula, then you won't be able to get it.
Yeah.
Okay, even how many bonding pair of electrons and how many lone pair of electrons are there, such type of questions are also asked in your past paper. So in ammonia molecule, how many lone pair of electrons will be there? There will be one lone pair of electrons and there will be three bonding pair of electrons. Okay, this was formation of ammonia molecule. Next part that is there is formation of methane molecule, which is
CH4.
CH4. So carbon, then hydrogen. First thing is its proton number is 6. So electronic configuration will be 2, 4. Proton number 1. Electronic configuration is 1. Here the valency will be 4. Okay, here valency will be 1. So if I write the valencies on the top, exchange the valencies to get the formula. This will give us the simplest hydrocarbon. That's methane, whose formula will be CH. Okay. Next part that is there is the structural diagram. Carbon is there. I'm showing only the outermost orbit. 4 electrons in the second orbit, outermost orbit. 4 hydrogen atoms. This is your 4th hydrogen atom.
Yeah.
Okay, first draw the carbon atom in the center. Okay, one more electron each of one of carbon and one of hydrogen. The nucleus of hydrogen atom. Okay, so this is your methane molecule. Okay, now how many lone pair of electrons are there in methane molecule? There are no lone pair of electrons. How many bonding pair of electrons are over here? Okay, there are 4 bonding pair of electrons. I can show the structural formula of methane as well. Okay, these are the 4 bonds of in methane molecule with carbon and hydrogen bonds. Okay, this is your structural formula of methane. We can show this in the form of electron dot structure as well. Okay, this is your carbon atom. These are the 4 electrons of carbon atom. Combining with 4 hydrogen atoms, this is going to produce
CH4.
This is the electron dot structure for
Ammonia.
methane molecule CH4.
Sorry, methane, yeah.
Okay.
Yeah.
Additionally, I'm taking one more example that is of
Carbon dioxide.
proton number
16. Oh, yeah.
this will be 2,4.
Yeah. It's 2.6.
Okay, here the valency of carbon will be 4 because it needs 4 more electrons
Yeah.
to make octet state. Oxygen needs 2 more electrons to make 8 electrons, that is octet state. So
Yeah.
valency of oxygen is 2. I can write down the valencies of carbon and oxygen on the top. Valency of carbon is 4. Valency of oxygen is 2. Common factor is there. This will be 2 ones and 2 twos. Now you can exchange these valencies, these numbers. This 1 will come over here. This 2 comes over here. So the formula of carbon dioxide becomes
CO2.
CO2. Now just see how the bonding is going to take place. Okay. See, carbon is sharing 4 of its electrons.
Yeah.
Oxygen is sharing, each oxygen atom is sharing 2 of its electrons. And how many such oxygen atoms are there?
2.
There are 2 oxygen atoms. So this can be shown like this in terms of bond, in terms of the structure. Carbon nucleus first. On the either side, we are going to have an oxygen atom. First, the nucleus. Six electrons in the outermost orbit. Similarly, for a second oxygen atom. Okay.
Yeah.
So these 2 electrons from oxygen and these 2 electrons from carbon atoms will get shared. Similarly, these 2 electrons of carbon and these 2 electrons of oxygen atom will be shared. Okay. So first you show the central carbon atom. When these all combine together, show the orbits first. 1, 2, 3, 4. And then the nucleus. Same thing will be there for the second side. 1, 2, 3, 4.
Yeah.
Now tell me how many bonding pair of electrons are there and how many lone pair of electrons are there?
Bonding pair is 2.
2 on this side and 2 on this side.
Yeah.
So total bonding pair of electrons are 4 bonding pair of electrons.
Oh, yeah. Yeah.
Correct?
And
Lone pair of electrons 1, 2, 3 and 4. So 4 bonding pair of electrons and 4 lone pair of electrons.
Yeah.
Now I'm going to show the structure of these. Carbon atom is in the middle. There are 4 electrons shared on this side.
Yeah.
Also 4 electrons shared on this side as well. This is a double bond. This is also a double bond. So there will be 2 double bonds. Okay. I can also show this in the form of electron dot structure. show the central carbon atom first.
Yeah.
Six electrons of oxygen. I can simply multiply this by 2. Carbon atom in the center.
Oxygen is
Okay.
yeah.
This is the electron dot structure of carbon dioxide.
Yeah.
Okay.
Yeah.
So these are covalent structures we have completed. Okay. Apart from this, formation of ammonium ion and hydronium ion. Okay. I'll just send you the link of the YouTube. You'll be able to see all this. And still, if you have difficulties, we can discuss that again.
Okay.
Okay.
Yeah.
Now we have here the ionic bond. We are starting with the simplest compound, that is sodium chloride.
It's alright.
Okay.
Yeah.
First of all, the definition of ionic bond.
When electrons are transferred.
Yes, is a bond formed by transfer of electrons.
Yeah.
So the first example is sodium chloride.
Yeah.
Always, this is the first step.
Electronic configuration.
Proton number is 11.
281.
Proton number is 17 from the periodic table.
287.
Now here by no means sharing is possible.
Yeah.
So one electron will get transferred from here to here. Because sodium is donating one electron,
Yeah.
therefore its valency will be,
Plus.
I'm putting the signs.
Yeah. Because
Okay.
you're moving.
Here it is accepting one electron, it's accepting a negative charge. Its valency is -1.
Yeah.
Sodium valency 1. You exchange these valencies.
NaC.
Okay, this will give you the formula of sodium chloride as
NaC.
NaCl. Okay.
Yeah.
So again, we'll start drawing the diagram for this. Just going to show the nucleus and the outermost orbit. One electron in the outermost orbit. Chlorine is having
7.
7 electrons in its outermost orbit.
Yeah.
This one electron will be transferred from here to here.
Yeah.
So when both of these combine together,
Chlorine will have one less and fluorine will have more.
this is the electron that has come from
Sodium.
Na.
Yeah.
This is having an extra electron,
Minus.
is going to carry a negative charge.
Yeah.
I'm showing just the nucleus of sodium. That electron is lost. So this is going to become positive. Okay. Now these are oppositely charged ions. Therefore, there will be a very strong force of attraction between them. What is this force of attraction known as? Electrostatic force of attraction. This electrostatic force of attraction is very strong as compared to the force of attraction that is there in covalent bonds. So ionic bonds are much more stronger than covalent bonds. This can be simply understood from the fact that the melting point of NaCl is nearly okay, in fact it's 892, but even if you remember, it's having very high melting point, approximately 900 degrees Celsius. If you consider other compounds like ammonia or methane, CH4 at room temperature, these substances are gaseous. Okay, so their melting point and boiling point of covalent compounds generally will be quite low as compared to melting and boiling points of ionic compounds. Next example that we are considering over here is that of
MgCl2.
magnesium chloride.
Yeah. Electron configuration.
Proton number is 12. This is 17.
282 and 287.
This will donate 2 electrons.
So 2 plus 2 and minus 1.
Okay.
Yeah.
So valency of magnesium
2 minus 1.
this one will get transferred over here.
Yeah.
So will come over here. Formula of magnesium chloride will be
4.
okay.
Yeah.
So now magnesium can donate 2 electrons, but chlorine can take only 1 electron. So there will be 2 chlorine atoms,
Yeah.
and the 2 of the electrons of magnesium will be given to 2 different chlorine atoms.
Yeah.
Okay, so that's why the formula becomes MgCl2.
Yeah.
We can show the bond formation of magnesium chloride. Nucleus of magnesium atom, the outermost orbit with 2 electrons. There are 2 chlorine atoms.
Seven electrons.
Okay.
Yeah.
So this 1 electron will come to this chlorine atom. The second electron will come to the second chlorine atom. And this is how the bond formation of magnesium chloride is going to take place.
Yeah.
So I can show the central magnesium atom. Nucleus is there. This is the outermost orbit, which has lost 2 of its electrons. Now because here 2 electrons are lost, so this will be written as 2 plus. Instead of writing 2 plus, you can also write plus plus. It's fine. Okay. It's better to write number, because when aluminum will come, then you will have to write 3 times. And suppose in case if you are having 4 positive charges, 4 electrons lost, then 4 times plus 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 you will have to write. Instead of that, it's better to write +2 or +3 or +4.
Yeah.
Okay.
Yeah.
Then you have the chloride ion, only the outermost orbit.
All right.
2, 3, 4, 5, 6, 7,
Yeah.
and that one electron from
Definitely.
magnesium. This will be single negative.
Yeah. That's good.
This will be your second chloride
Single negative.
ion. Okay, that will also have single negative charge. Okay, this is formation of molecule of magnesium chloride, that is MgCl2.
Yeah.
Next one is formation of magnesium oxide.
Yeah.
Proton number 12. First we'll get the electronic configuration.
2H2 and 2.
This is donating 2 electrons.
+2.
This will be accepting 2 electrons.
9.
Okay.
Yeah.
Valency of magnesium is 2. Oxide or oxygen valency 2.
Yeah.
This is a common factor. So formula of magnesium oxide
Yeah.
will be M0.
Yeah.
Okay. So there is a single magnesium atom showing only the outermost orbit.
Yeah.
Plus here oxygen atom, nucleus, outermost orbit. Two electrons donated.
So it's 2 plus and 2.
Okay, I'm showing the outermost orbit. 2 electrons are lost.
Yeah. Plus
It will be valency
2 plus. Plus.
or +2.
Yeah.
Oxygen nucleus, outermost orbit.
It's
This
minus.
is going to carry 2 minus. Okay,
Yeah.
this was formation
Of MgO.
of
Magnesium
magnesium
oxide.
that is MgO.
Yeah.
Next example that I'm taking is of
Aluminum oxide.
okay.
Yeah.
First the symbol from periodic table, proton number 13, and this is
8.
next thing is its
Configuration.
electronic configuration.
2 and 2 6.
This will be 2 6.
Valence is +3 and -2.
We will donate 3 electrons to make octet for this orbit.
Yeah.
The valency is +3. This will be having valency.
-2.
Okay.
Yeah.
So aluminium valency 3, oxygen valency 2. Just exchange these valencies.
Yeah, 2.
Formula of aluminium oxide will be Al2O3.
Oh, 3.
Okay. Now aluminium can donate 3 electrons, while oxygen can accept only 2 electrons in one orbit. So there will be 2 aluminium atoms. How many will be the total number of electrons given by 2 aluminium atoms? 6 electrons. 1 aluminium will give 3 electrons. 2 aluminium will give 6 electrons. While for oxygen, if you are considering, one oxygen atom can accept 2 electrons. So 3 oxygen are going to accept 6 electrons. Okay. So basically here there will be 2 aluminium atoms which will give 6 electrons, and these 6 electrons will be distributed amongst 3 oxygen atoms.
Yeah.
Okay. So I can show the figure like this. 2 aluminium atoms, 3 electrons each in the outermost orbit, 3 oxygen atoms, this is your second oxygen atom, and your third oxygen atom. Okay. Your third oxygen atom,
And now you get short.
2 electrons will go here,
2.
2 electrons will go here, and these 2 electrons will go here. Okay. So these all will combine together.
Yeah, 2.
Okay.
Yeah. And oh. 2 minus.
2 minus.
This right is 3 in front of them, multiplied by 3.
Yeah, we can write like that also. You can simply, instead of writing these both this way, you can just write this as 2 and this as 3.
Yeah.
Okay. This was formation of Al2O3.
Yeah.
Okay.
Yeah.
So we have considered here formation of covalent compounds and ionic compounds. Okay.
Yeah.
I'm just taking the comparative properties of covalent compounds and ionic compounds. How are covalent compounds formed?
By sharing of electrons.
Formed by
Sharing.
sharing of electrons. These are formed by
The transfer of electrons.
okay, will be containing neutral molecules.
Oh. Yeah.
This will be containing charged particles called ions. Generally, low melting point and boiling point.
Yeah.
This will be having
High melting and boiling point.
generally bonds are weak.
Yeah. Yeah.
This will be having strong bonds. More comparison properties. Generally insoluble
Water.
in water but soluble
Yeah.
in organic solvents like carbon tetrachloride or carbon disulfide. Okay,
Yeah.
this will be
Soluble in water.
soluble in water but insoluble in organic solvents.
Yeah.
This will be
Poor conductor of heat and electricity. They are good conductor.
okay. This will be generally good conductors of electricity in aqueous or molten state.
Yeah.
Okay, this will not be able to conduct electricity in the solid state because the ions which are there, they will not be free to move.
Yeah.
Okay,
Yeah.
so this will be the comparative properties of covalent and ionic
Bond.
compounds.